hold on. If I get 1,000 subscribers, you'll do what?
I will give you a certain level of respect.
A certain level of respect.
I'll probably give you money too.
I don't need your respect.
Yeah.
If I wanted your respect, I'd try to be like, I don't know, something else.
I'll give you money. I'll pull you off the ball.
We speak no evil. Respect all of my friends.
JD will probably give you money
Okay.
too.
All right, so here we go. So we are a little bit. So story time. So Derek in high school had this girlfriend junior year, right? And her family loved playing cards, which was great. Except my family never really played, right? Like we played Go Fish and crap, but like we never played actual cards. And so when I go over to her house to play euchre, which was a terrible idea because every time I get taught a new card game, I forget the rules immediately after I'm done playing and have to be taught again every single time. And euchre is a complicated game, and you play in pairs, right? So we were paired up against her family, right? And we're playing this game. It's my turn to shuffle because I'm gonna deal. And I'm shuffling like this, and they're all making fun of me, right? Because I don't know how to do the bridge, right? Okay. And so eventually I learned, but a lot of trauma I had to work through first. Part of it was here. So what would happen is I'd deal out, right? We'd get our hands, and then you're supposed to play cards, right? You're supposed to work together as a team without talking, I think is something like that. I haven't played euchre in years. Again, psychological scarring. And so I'd play a card very hesitantly, like this, and I'd put it down, and her family would be like, yes, because I did something stupid, and she would be so mad at me. That relationship did not last long. So that's the thing. So what we're going to do is we're going to teach you a little bit about dealing today, okay, and how it's done. So normally you probably deal like this, right? 1 for you, 1 for you. 4, 6, 8, 10, 12, something like that. Maybe you count each one, right? Maybe you don't. I don't know. So what happened was I dealt 12 cards, and I dealt 1 to each person, 2 people playing this game, right? So how much of the 12 ended up here? We have 6 and 6, right? So if the deck was 12, how much of the deck got dealt to each person? How much of the deck got dealt to each person? 6 cards, but how much of the deck?
12.
Half. Unhalf, right? I know. It's hard to ask that question. My fault. Question was bad. Answer is fine. So half to each person, right? Cool. And how did I deal that? Well, I did 1 to you and 1 to you. We call that a ratio, okay? For every 1 I dealt there, I dealt 1 over there. That's it. That's a ratio, okay? Now check it out. Check it out. So I shuffle the cards, right? Because we've got to redeal, right? Here's my beautiful shuffling, right? With my bridge, okay? Or lack thereof. So if I deal again, maybe I want to be creative, right? Really show off. I could deal like this. 2 for you, 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 and 2 for you. How much did each person get?
2.
Still half, right? But I dealt differently, 2 to 2. So it turns out these are equivalent. They produce the same result, don't they? Okay. So if I dealt 3 and 3, I bet you could imagine what happens, right? 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Boom. We still have 6 cards everywhere, right? Half and half, right? So 3 to 3 is equivalent as well. So it turns out, if you start with a ratio and you multiply both sides by the same number, it's still equivalent. So if I multiply 1 by 2, I get this, right? If I multiply both sides by 3, I get this. I bet you could figure out what I do if I multiply by 4, right? It would still be half and half. Or I could do 6 and 6, et cetera, et cetera. So that is an interesting way of dealing. But what if you're playing a game where not everybody gets the same amount of cards? What if one person's supposed to get a third of the deck and the other person's supposed to get 2/3? Now I suppose you could be like, count all the cards, right? Okay, this game has 12 cards in it, right? So what's a third and what's 2/3? Well, we have a quarter, or 4 and 8, right? I could do that. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. I could do that, right? But that's really lame. That ratio would be this, right? 8 to this side and 4 to that side. I did it all at once, right? What would be an equivalent ratio, a smaller ratio? 8 to 4, 2 to 1, right? The way he did that is he divided by 2 and got 4 to 2. Divided by 2 and got 2 to 1. That's the simplest ratio. So what I could have done to be more clever and be cool is to deal 2 to you, 1 to you, 2 to you, 1 to you, 2 to you, 1 to you, 2 to you, and 1 to you. And remember, I was originally trying to reach 2/3 of the deck to you and 1/3 of the deck to you. Well, let's check it. We have 12 cards total. How much is a third? 4. 1, 2, 3, 4. And by simple math, you know there's 8 in here, right? Yep. So I did it. So I could do it the lame way, or I could do it the way more interesting way. You get 2, you get 1, you get 2, you get 1. And it divides it up into thirds, right? There's no 3 here. Isn't that bizarre? Right? So what if I wanted to, I don't know, let's pick a different ratio. Something else, a different set of fractions, and figure out what their equivalent ratio is. How about I want 2/5 of the deck to go over here and 3/5 of the deck over here. Now, notice I have 12 cards. Is 12 divisible by 5? No, so I'm not going to be able to get fifths. So I need a number that's divisible by 5. What's the next number up that's divisible by 5? 15. So I add 3 more, right? So now I've got 15, okay? 15 cards in here. So what I'm going to do is figure out what the ratio is that I should deal to do the most back and forths, right? I could do 1, 2, 3, 4, 5, 6, 7, 8. Sorry, I lost track. 15, 3, 9. 1, 2, 3, 4, 6, 7, 8, 9 over here, and then do the remaining 6 over here. That would be lame, right? I'm trying to impress a girlfriend's family. So what do I do? What's the ratio I'm going to have here? you see the pattern? When we wanted half, we did 1 to 1, right? When we wanted 2/3 and 1/3, we did 2 to 1. What am I going to do here? 2 to 3. 2 to 3. So I'm going to try that. Let's do 2 to 3 and see if it works out. Remember, we need 9 cards over here. That's 3/5 of 15, and 2/5 of 15 is 6. So that's what we should end up with. Let's try it. 3 for you, 2 for you. Can you see me? 3 for you, 2 for you, 3 for you, 2 for you. Well, it comes out evenly. That's good. Let's count them up. 1, 2, 3, 4, 5, 6, 7, 8. Oh, crap. Did I count wrong? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, man, I blew the trick. So 6 over here. 1, 2, 3, 4, 5, 6, and 9 over there. Man, cards slid together. They're brand new in my defense. So 2 to 3 gets us a 6, 9, right? Split. Are we cool? So ratios and fractions are related in kind of a weird way. The numerators of these fractions tell you the ratio. And if you add up the ratio, 2 plus 3 is what? 5. So if I want to split something into fifths, I don't necessarily have to divide it by 5. I could think in terms of ratios. I could split it into something that adds up to 5 as a ratio, like 1 and 4, or 2 to 3, or 3 to 2, right? So there's a different way of thinking about it, which is useful because in that critical thinking problem I gave you last night, you were all thinking, oh, to find a quarter of the way, I'll divide by 4. How'd that work? Or maybe you thought, oh, to find a third of the way, I guess I'll divide by 3. How'd that work? You were using the wrong language. You were using fractions, which are wonderful, and I'm going to prove to you that they are. I did it with algebra the other day. It blew their minds. Fractions are taught to you in the most stupid way from 3rd grade onward. Right? Let's split up the Hershey bar. Right? How much is this? And that's all fine and dandy. That's useful. But then you go to do stuff with fractions, and you're just completely lost. I'm going to show you that fractions aren't that scary. Okay? But that's not today. Today we're going to talk about ratios. Okay? And we just learned what equivalent ratios are. 2 to 1, 4 to 2, and 8 to 4 are all equivalent. Because when you start with the basic one, you can multiply both sides by 2, multiply by 3, whatever you want. As long as you do it to both sides, it's fine. Remember, that's algebra. Have we talked about that in here? Probably not. Are you ready for this? Okay. So, if you do it to one side, this is child abuse, right? But if you do it to both sides, it's algebra, right? That's what they taught me in school. Okay, so as long as you do it to both sides, it's all good. So what's an equivalent ratio to 2 to 3? Give me an equivalent ratio. 4 to 6. Give me another one. Give me something interesting. Think of a really funny number. There we go. 6 to 9, right? We times 3 both sides. There we go. Nice. Nice. 420, 69 IQ back there. All right, so here we are. See how this works? Wunderbar. That is wonderful in German, I am led to believe. All right, so here's the problem of the day, okay? And it's not you.
Yeah, it's not you, it's me.
Okay? I get that a lot. All right, so here it is. Okay, I'm going to not throw it up on the board. I'm just going to write it down, okay? Using the numbers 1 through 9 only once. This is going to be on your warm-up. This is your warm-up. Oh, move the paper down. Okay, got it. Using numbers 1 through 9 only once. Fill this out to make it true. We have a ratio of 1-digit numbers, okay? So like 2 to 3, okay? And I want that to be equivalent. Let's use a different color. Where are all my pens going? Equal to a ratio of a 2-digit number to a 1-digit number. But wait, there's more. And I want that to be equal to, all of these are going to be equal, a 2-digit number to another 2-digit number. Now check it out. What do you notice about this problem first before I set you loose and let you work together? Let me play the song today. Huh? Ratios. What else do you notice?
They're all equal to each other?
They're all equal to each other, so these need to all be equivalent. These two are equivalent to each other. So are these, right? What else? We have 2 1-digit numbers, or 3 1-digit numbers. Yeah.
Then you gotta double to 1.
Something about that. Anything else? How many slots do we have here?
I count 6.
2 plus 3 is 5 plus 4 is 9. So we're going to use every number once, aren't we? Can we use 0?
No.
Now remember, when life gives you a problem, and most of the time life does, right? And when it gives you a problem, it's not an easy one, otherwise it wouldn't be a problem. At least it's not one worth solving. Sometimes it's easier to make yourself learn something about the problem when it's easier to work with, right? So maybe ignore this for now. Make that true. Maybe ignore the 1 through 9 only once, right? Screw your rules. I'll do what I want. Come up with something that works under that. Learn something about the problem. Try to figure out the rules. Because see, the problem with life is that there's so many possibilities, right? So you're sitting with your significant other, right? And you're saying, I'm hungry, right? And so what do you say? I'm hungry. What do you want to eat? And what do you say? I don't know. What do you want to eat? And you go back and forth. You know why that happens?
No.
Because there's infinite possibilities and it's overwhelming. And so what you do as a good significant other is you say, could I have some options? Or maybe, could I present you with some options? And then you narrow it down. You're like, okay, how about Pizza Hut, Taco Bell, or McDonald's? Now, I bet when I listed those, you instinctively came up with an opinion, didn't you? Right? What's your opinion? Pizza Hut, right? So, boom, we went from infinite possibilities to we have an answer. Now, sometimes the answer doesn't happen, and that's life, okay? But we start eliminating from the infinite, and we come down to the finite, and we're able to get to a decision before someone gets hangry and we have, we end up in divorce, right? Okay, true story. So, 3 possibilities, a lot better than infinite. So what you need is take the infinite, right? I mean, well, I don't know, right? And start eliminating stuff. Learn about this problem and what the other restrictions are. I didn't write down all the restrictions, but there are restrictions here. You're going to notice it as we go throughout this thing, that using 1 through 9 only once is a restriction. Okay, and we're going to obey that. But there are also other things inherent within the problem that restrict you on possible things you could do, right? And that makes sense because not everything's a solution. There are not infinitely many solutions. There are infinitely many possibilities. As far as I'm aware, there's only one solution. And I didn't know it before I started first hour this morning. I did this flying blind. And every class today has figured it out. But remember, it's not about getting the solution. It's about the journey along the way. It's about learning about the problem. And the problem is life. Okay? What you do is not important in life. It's who you do it with. Partner up. Talk. Get it done. I'm going to give you 5 minutes, and then we're going to talk about it, okay? Work together, just like you should on your homework. The song of the day is Between You and Me by the band DC Talk, which I think is relevant because we're talking about midpoints.
Man, you want to be my buddy?
I have no idea how to do this.
Me neither. Oh, hey, man.
Back, one there.
Excuse me, sir.
Yes.
Autumn's getting picked up.
Send her my condolences, please.
She's not stable right now.
I understand. Tell her I'm thinking about her. Speaking of cards, Game Club is nice 3 to 5. We have every Monday and Tuesday. You want to be here today because we're going to take attendance for pizza next Monday. If you're here, I can write you down for some pizza. Right? We can't do this one.
She says thanks.
Back to the problem. Back to the problem.
She says thanks.
Good. Okay. Tell her I worry about it. I really do. Good kid.
Me too.
Miss her very much. You got 3 more minutes. Again, we're not looking for a solution here. We're looking to learn about the problem. You're not going to get the solution in 3 minutes, okay? That's not the point. Who cares about the answer? Work together. Try things. Take chances. Make mistakes. Get messy. Miss Frizzle, right? Best teacher. Any school bus? Anybody? No?
Yeah, man.
Time's about halfway over.
Can I have your guidance? Okay, so this.
Try it out.
Oh my You don't care about the solution?
I mean, no, it'd be nice, right? We like we end up where we expect to end up, but the journey's way more important. Tell me something that you've learned about the problem, stuff that doesn't work, right? It's okay. You don't know how to problem solve yet. Today we're gonna learn how to do it, okay? It's okay. You guys know how to follow steps.
Yeah, that sounds good. It's much.
Our teachers suck.
No. That we speak no evil. We speak no evil. Unless it's about me. Nuh-uh.
You don't even know him.
I'm about to
Doesn't matter.
Mary just said it.
None.
This guy named Patrick Ross.
None.
What?
One minute. Where is Saddam? Found Saddam. Ladies and gentlemen, we got him. They're all way too young for that joke.
Excuse me, sir.
I don't know what you said. All right, we're gonna call it a day there. I know it's not your complete time, but it's close enough, right? So, you have any wisdom you want to share with the class? Anything, any insight that you got?
I do not like.
Okay, so here's the deal. Another life lesson. So life, a lot of time, has time constraints, right? You got to figure out the solution now. You're on a time schedule, right? You got to figure this out by next week or whatever it is, right? And a lot of times that's not enough time. And that sucks, right? And maybe you don't figure it out. But you're going to learn something in the process one way or the other, right? Maybe better time management is what you're going to learn, right? But you're going to figure out something about it. So today we're going to learn how to problem solve. We're not going to solve this problem, but we're going to learn how to go about solving a problem, okay? Maybe we'll get it, maybe we don't. So far I'm 5 for 5, okay? But we'll see. So, what did you do? What was your strategy? Maybe you didn't have a strategy. If it wasn't your strategy, what did you do? Tell me. Rosie, yeah.
Throw down numbers.
Throw down numbers. What numbers do you throw down? Let's throw down!
1, 2.
1 and 2. Okay. Let's stop there. So 1, 2. You pick those because they are the lowest numbers in numerical order, right? So why not? Let's try that. So we have 1 and 2. Now what does this lock us into, right? Well, first of all, we already used 2 of our numbers, so we only have 7 more, right? 3, 4, 5, 6, 7, 8, 9. Whoops, well, there it goes. Okay, so notice what this ratio means.
Can you catch?
Thank you. That means whatever here doubles to become this, right? That's the ratio, the relationship. If you get 1 card, this person gets 2. I could also do, you get 2 cards, this person gets 4. You see what I'm saying? The relationship is times 2
I feel like an idiot.
between these two. It's okay.
I like got myself literally like depressed about not being able to do that, and then I realized how dumb it was.
In 5 minutes? Okay, don't do that. Not knowing something is good. That means there's something to learn. Seriously, you're so used to being in school where the solution's so easy that if you don't get it, you should be dumb, right? Or if you, do get it, it's like, well, what's the point?
Yeah.
I don't get problems like that. I get problems that if you don't get it, that means that's great. That's a good problem. And 2, it's not because you're dumb, it's because it's a good problem, okay? You understand?
Yeah.
I do that for your self-esteem. Not really, I don't care about that, but let's pretend I do, okay? So here we go. 1 to 2 means that you double the left side to get to the right. So whatever I write here, I multiply it by 2, and that's what ends up here. So what do you want to put here?
4, 3.
Okay, so we put 4, 3. So now, to keep the ratio, I need to double it. See how this goes double? So that has to double. What's double of 43? 86.
But there's no.
But it's 1 digit. What do you notice? What does this mean?
It's not.
That doesn't work. Yeah, but not just this specific solution. What else? Come on, think. Think. Why doesn't this work? Check it out. We have a 2-digit number that when we double it becomes a 1-digit number. The bigger number gets doubled and becomes smaller. We done goofed. So what do we learn? What do we learn about this problem?
You can't go higher, you gotta go lower.
Exactly. So the higher number has to be on which side? The left or the right? The left side. Let's write that down. That's problem solving. We just learned something. Left is bigger than right. So the left side of each of these is going to be bigger than the right side. This guy's going to be bigger than this. This guy has to be bigger than that. That has to be bigger than that. So instead of reinventing the wheel, how about we just switch them, right? So here we go. I'm going to fill it out again. Again, I wish I was doing this on a whiteboard, but I don't have a camera to capture it. I think this is important to capture. I didn't capture it first hour, and man, do I regret that with my entire soul. That was beautiful. It was a work of art. Okay, those kids.
Must be nice.
2 to 1. Let's try that. So now what does it lock us into? It says that we're going this way to times 2, right? So whatever we put here, we have to double to make here. So what do you want to put there?
6.
6. Why not, right? So I put a 6 there. What do I get here? 12. Is that a problem?
No.
Let's try it. Does anybody notice something? It is a problem. Why?
Because the smaller numbers on the left.
No, that's fine. Bigger numbers on the left. We want that, right? We got 12
We
here.
already pushed
It's double digit. Yeah, Tim Allen, right? All right, so do you see the problem? We already used the 1 and the 2. So we can't do that. So scratch that. Not 6, not 12. We didn't mean 6. Pick another number.
25.
We need a single digit right here.
Well, I don't think we get because 8.
You're right. Don't spoil the trick yet, okay? That was beautiful. That was brilliant. Thank you. Okay, so we put 7 here. We get 14, right? Is that a problem? Yeah, because we already used the 1. What about 8? We get 6. We already used the 1. 9, we get 18. We already used the 1. We have to use a number smaller. How about 5? Oh, we used 10. Already used the 1. Can't use a 0. What about 4? Produces a single digit. So what have we learned? The 1 has to go here. No, when you double a single digit number, it's always going to produce a 1 or a 0 there, isn't it? 4 doubled is 0, 8. 5 doubled is 1, 0. 6 doubled is 1, 2. So the 1 has to go here. Did I make you choose these numbers in the beginning? No. This is problem solving. I don't know where this is going to go, but we're finding out stuff that we might not have found out in other hours, which is exciting. So the 2 to 1 isn't going to work there, but the 1 does have to go here. Have we even worried about the right side yet, like this part? No. Who cares, right? So here's the thing. When we choose a new ratio, we can either go to 1 to 1 here. It doesn't work. Right? Repeats it twice. Bummer. Right? Or we got to go bigger, right? 3 to 1 maybe? Or we could go 2 to 3? Which one do you want to try? 2 to 3 or 3 to 1? 2 to 3. Okay, so 2 to 3. Oh, bigger number has to go on the left, right? So 3 to 2. Now what does this mean? How do I get from 2 to 3 by multiplying? I multiply by halves. Very good. That's going to get nasty. You know what I mean? Maybe that's the solution. It ain't, okay? It's going to give you fractions. We're not allowed to use fractions for some numbers, right? Like 3 halves of 5 is going to get 15 halves. That doesn't work, right? So it's going to screw up something later. But when you are presented with something like that, where it's confusing and complex, right? We got to multiply by 3 halves. Exhaust all the easy stuff before you get to that, right? So let's not do 3 to 2. Let's do 3 to 1. So what did we learn, right? Try the easy solutions first. Okay, so we're going to go 3 to 1. Oh, we can't do that. Sorry. Let's try something else. 3 to 2. We already did that. How about 3 to 3? No, that doesn't make any sense. Is there another way we can write 2 to 1?
Yes.
How? 4 to 2. Let's try that. Okay, so we still have the relationship of times 2, right? That's nice. So whatever goes here doubles and becomes something with a 1 next to it. So what does that mean about this number right here? Can it be a 4? Why not? Because 4 times 2 is 8. So it has to be bigger than 5 or 6 and up, right? Like that game you love playing, right? I don't know. Everything's 6 and up. Yeah. So this number has to be bigger than 6. 6 or bigger. Because if it was 5, we get a 10. We can't use 0, right? If it's smaller, we get a 0, 8. Like 4 times 2 is 8. You with me? Okay. So 6 and up. Which number do you want to use? If we use 6, we get a 12, so we can't do that. Let's use 9. Okay. What do we get when we double it? 18. Is this a solution for this part? It is. So we successfully completed this problem. Good job. What numbers do we have left? Well, we've used 1, 2. We haven't used 3. We haven't used 5. We haven't used 7. And we haven't used 6. I should probably write these in order, shouldn't I? Okay. Before we start in checking, think about what we're doing here. We're timesing by 2, right? Think of a number. Everybody think of a number, a single digit number. Got it? Multiply it by 2. No, multiply by 2. That's it. Hang on to that number. Is the number you now have even?
Yes.
Thomas? How about you? Is it even? How about your number? Is it even? Is your number even? Is your number even? Is your number even? How do I know it's even?
Everything multiplied by 2 is
Whenever you multiply a number by 2, it produces a even number. So what do we know if this number gets multiplied by 2? What is this number going to be? Even. And how do we know a number's even?
It has a 2, 4, 6, or 8 on the end.
Boom! Right there! Nailed it! A 2, 4, 6, or 8 here. So what goes here? Either a 2, 4, 6, or 8. So more importantly, this digit is even. Now how many even numbers do we have left? 1. So let's try it. 6 has to go there. All right, so now we need a number when we double it, produces something with a 6 on the end. So let's start small. 35 is the smallest number I can make here, yeah? So I put 35 here. What's a double of 35? 70. First of all, doesn't end in a 6. Let's start a little bit bigger. How about 36? Oh, can't use it. We already used the 6. 37. Double it. It's going to end in a 4. No good. How about 53? 53 doubled. What happens? 106. It has a 6 on the end. We got it. Why not? It's too big. Oh, it's 3 digits. So wait a minute. What do we know about this number then? It has to be what? Boom! It has to be smaller than not 53, but smaller than... Does 52 work? No, because that's 3-digit, right? 52 times 2 is 104. It has smaller than 50. Because 100 is 3-digit, right? So smaller than 50. I'm guiding you a little bit here, but you guys are doing most of it. You guys are much more efficient than my others, but you're still doing most of it. All right. So we know that that 6 can't be there. I mean, it does have to be there with our current setup, right? We need a different even number there. So let's rethink how we did this. Okay? We know that this number over here needs to be what? Less than 50. Okay? This has to be even. And this has to be even. And this has to be even. Oh, sorry. Did I goof it? Yeah, I did. Even here. Even here. Even I'm so confused right now. Pause. All right. Sorry. Let's rewrite this so it's a little bit easier to see. So I have single digit number, colon, single digit number, then an equal sign. The equal signs being in different colors really helps, right? That's why we do math and color. Equals 2-digit, colon, 2-digit, 2-digit. Okay? That's not the cap for that one. All right. So here we are. We know that this one has to be 1, right? We learned that earlier from here. It has to be, because any single digit number multiplied by 2 is going to produce a 1 here. And again, we're assuming that our numbers here are correct. Maybe they aren't, but we're starting basic, okay? Based on that 2 to 1 in theory, right? We're going to write it differently. Based on that, this has to be a 1. We also know that this has to be even, because after you double it, it becomes even. After you double this, it becomes even, so that's an even number. After you double this, this becomes even. What numbers do we have to work with? 4, 2, 4, 6, and 8, right? So we have 3 slots and 4 even numbers. That's limiting our options, isn't it? And that's good, because then we can come to a conclusion, right? So we only have so many slots for even numbers. So we tried 2 to 1. We tried 4 to 2. That didn't work. What's another equivalent ratio? 2 to 1, 4 to 2. 2 to 1 is the same as 4 to 2 is the same as 6 to 3. Let's try that. A 6 here and a 3 there. Okay. So what numbers do we have left? Well, we have 2, we have 4, we have 5, we have 7, we have 8, and we have 9. What number do you want to put here?
7.
7. Why not? So we put a 7 here and we get a 4 there. Okay, that's fine. So we've used the 4, we've used the 7. We need an even number here. So what has to go there? 2.
Can you screw out like 2 or the 1, whatever that is in front of the 6?
The 2 and the 1 in front of 6? Yeah, I can.
No, like next to the 6.
Oh, scribble it out more? Yes. Does that help? Okay. So now we're here. This has to be less than 50. Can I make a number less than 50 using these numbers? No. So that can't be a 2. Which means that can't be a 7, because then that means it's a 4. So let's scratch these out. The 4 has to go here, doesn't it? What do you want to put here? A 5? Well, we get a 0 there, right? Because that's 10. We're bigger than
Either get a
6.
5 or a 0 for
We put an 8, we get a 16. Already used a 6. What do you want to put there? 9. What do we get here? 18. Ah, the 4 does have to go there, right? We've used every number except 2, 4, 7, and 5. So let me write those down. 2, we just used the 4 there. 7, and 5. 27 where? Well, it has to be less than 50, so this one, right? What's 27 times 2? All right, forgive me. That's dope as hell, right? Like, that's sick. That is sick, right? That's what it's all about. We don't care about the solution, but what do we learn along the way? Let's go back to the beginning. We learned that the left side has to be bigger than the right side, because when we tried it, we ran into a brick wall. We learned that the 1 has to go there, because when you double a single-digit number, it becomes a 17, 18, something like that, right? We learned that we could rewrite 2 to 1 as 4 to 2, and it gets rid of our numbers better. Saves that 1. We learned that these have to be even. Why? Because when you double any number, it becomes even. And that really limited us, right? You didn't get this, but another class noticed. You want to get rid of your big numbers first, right? Because if they're too big over here, you're not going to be able to be less than 50. You sort of got that, right?
Yeah.
Because if it's bigger than 50, then we have a 3-digit number. I really enjoyed this, and this one's on tape. Yeah.
Is there other solutions to this?
That's a great question, and that's the next question, right?
Yeah.
Is this the only solution?
Let's just say yes and move on.
It's the only one working with a ratio of 2 to 1. You know what I mean? 2 to 1. It's 6 to 3, right? But what about others? It's a great question. You want some self-development? Find another one or prove, okay, as best you can. I know you don't have to prove things yet, but as best you can, that there are no other solutions. That's a real math problem, what he just asked. That's interesting. That's worth solving. That is something that is not somebody knows the answer already. It's the back of the book. That's math. 2 plus 4 is not math. 2 plus 4 is calculation. And that's valid and it's important, and I guess it's part of mathematics somewhere, right? But that isn't what it's about. You're not going to use algebra, geometry, all this stuff every day. You're not going to use it probably once a year. I'm not going to lie to you. I'm not going to BS you. I don't do that in here, okay? I tell you how I feel. But you are going to use the reasoning that we do in here every day of your life, and it's going to make it a lot better. When am I going to use this? You're going to use this when you're trying to figure out where to go out to dinner with your significant other.
66.
Or your grandma, like me, when I go see my grandma on Thursday and take her out, right?
Spin wheel, spin it.
You do that too, right?
Yeah.
Then we not talk about probability, but still. Okay. So yeah, but now I'm reaching, and I don't want to reach. That was your warm-up for today.
Great. A 34-minute warm-up.
I love it. I love it. All right, so now you know about ratios. It's time to talk about the homework. So get out the homework real quick. Here it is. Trade and grade. Here we go. We're only doing the front side. Check the answers. All right, all wrong. Unless they're missing a negative sign, or, you know, they got it negative when it should be positive, positive when it should be negative. I trust you to be a good judge of that, okay? So notice number 1, the answer is -3, -3. If they wrote 3, -3, take off half. If they wrote 3, 3, and make them redo it.
You gave us that.
Oh, enough. I know. Some of you weren't here, though. Okay.
It's -3, -3.
So number 1 is -3, -3. Thank you. Number 2 is -3/2, comma 0. 0 divided by 2 is 0. Again, how did I come up with that? Well, 2 ways. 1, I plugged in the numbers and did the math, right? I can check my work like this. Zoom in. Here we go. Number 2, take a look at it. It's right here. Are we okay? Check it out. Check it out. So a way to eyeball it, the geometric way, the non-algebraic way, right? We draw our triangle. The vertical portion is 10 long, okay? What's 10 divided by 2? 5. So if I go 5 down, that's its midpoint, right? The horizontal portion, it's not a nice number, it's 7, but what's half? 3.5. So I go there, there's its midpoint. When I take out Saddam, right, I draw my lines, and where they intersect is going to be the midpoint. So there's my midpoint. Now check it out. That's kind of a weird midpoint, but I know what it is. From here, it's 5 down. If I go 5 down, I get to 0, right? So that's my y value. My x value is the complicated one, right? It's got like 1.5. How do we know it's 1.5 and not 1 1/3? Because this is 3.5. So how much is left in this square? A half. So I have 1 plus a half. It's 1.5 to the left. 1.5 to the left. Now, Fractions are better than decimals. I don't have time to teach that. Okay, we're going to get to algebra. We're going to do that. Okay, but let me show you one way that they're better. Negative 1.5, sure. Maybe you know negative 3.5 is 1.5 because you've been doing it your whole life without a calculator because you had to do this because you prefer decimals. What if we didn't know? Let's count by halves. 1/2, 2 halves, 3 halves, 3 halves. Don't say 1.5. 1/2, 2 halves, 3 halves. 3 halves. It's like having 3 chickens, right? You write 3 and then you write chickens after it. It's like a unit. You have 3 halves. Figure that one out. Number 3. The answer is negative 1 comma negative 3 halves. And if you check it, let's do that. Negative 1 to the left, and then negative 3 halves down. Let's count by halves. 1/2, 2 halves, 3 halves down. That's better than negative 1.5. It's going to be a lot better than the next one. I'll show you. So look, we draw our line 2.5 is away. We draw our line 2 is halfway. Which sect is here? 1 to the left, boom. 2.5, that means I have half left over, and 1. Negative 3 halves. And 1. Number 4. Again, tell me if you can't see stuff. I'm going blind, okay? Flying blind is what I meant. So I draw the lines. Boom. 2.5. Boom. 1.5. They intersect. There's our coordinates. I do the math. There we are. Again, we count by halves. We're 1. Let's count. It's negative 5 halves, right? Let's count by halves to figure it out. So from here to here, that's 1/2, 2 halves, 3 halves, 4 halves, 5 halves. Boom. Negative 5 halves. What's negative 5 halves in decimal? Exactly. Don't worry about it. Just circle it. Count by halves. It's better. We go up by 3 here, or 3 halves. 1, 2, or not 3 halves. We go up by 3 halves. 1, 2, 3. 3 halves from the x-axis. From there up. Turn the page. Number 5. I don't think you guys read the directions. They don't give you 2 endpoints. We're used 2 endpoints and finding the midpoint, right? That's not what they asked. They said endpoint, midpoint. So they give you the midpoint, want to find the endpoint. So the midpoint is negative 9, 10. We know one of the endpoints, so I plugged that in. We don't know the other one. You smell what I'm stepping in?
Nope.
Thank you for saying that. So they give us the midpoint. That goes here, right? Midpoint equals average of the x's, average of the y's.
Yep.
So I know midpoint goes here. My average of the x's, well, I'm talking about the x's for my endpoints, right? The 2 things here. Well, I know one of the endpoints is negative 1, and the other one is 9 for the y value. What's my other endpoint? That's not what I'm looking for. So I call it x and y. Now this looks weird. Midpoint is a point, right? So this is a coordinate. So it's something comma something. So this part right here should equal this part of the midpoint, shouldn't it? Those two equal each other. Negative 1 plus x over 2 should equal negative 9. 9 plus y over 2 should equal 10. I set them up, I knock them down. Take a gander. Number 6 is on your own tonight for homework.
Oh, where? Oh, there's no homework? I didn't do it. Okay.
There you go. Snap that. Put it on the timeline. Here we go. Get it to the IG. I'm moving down. Number 6 is on your own. 7. Find the point that is a quarter away. Did anybody come up with a clever way to find a quarter of the way between 2 points?
No.
No. Anybody? You figured it out? How'd you do it? Yes! Excellent job, May. All right, so check it out. Here's what May did. She found the midpoint, and we know how to do that, right? And then she went back, and instead of plugging in the endpoints again, which would just get you the midpoint, she plugged these 2 into the midpoint formula and found the midpoint of the midpoint. Boom! That's what I'm talking about. Nice job, kid. That is self-development points right there. I'm going to give you 2 of them, okay? So here we go. Number 8 is for self-development as well, okay? Now, May's idea was brilliant because it got the midpoint of the midpoint. If I wanted to find the quarter point, divide half by 2, you get a quarter. If I want to find an eighth, divide a quarter by 2, you get an eighth. If I want to find a sixth, oh, I'm kind of screwed, right? What about a third? Also kind of screwed. You need to really think about this one. So the idea for this one, again, words are hard, math is easy. Let me explain the words. They say the endpoint is 8, negative 1, and they tell you the midpoint is 5, negative 2, and they want to know where's the endpoint. And they tell you that it's not a midpoint. They tell you it's a third of the way. So if that's a third, how much is left over? 2/3. How do you do it?
That's crazy. Ratio. Yeah.
What's the ratio between 1/3 and 2/3? What's the ratio? 2 to 1. You're going to want to divide by 3, but that's not going to make set it up right. There's something with these guys. Get out your notes. Section formula, real quick. Here we go. I'm going fast. Watch up here. Here we go. The first page of the notes for section formula. Oh, it's upstairs. You don't have them. That's right. I'll grab them for you, okay? I tried printing them. They won't. I don't know what's going on. Whoever keeps stealing your stuff is annoying me. I'm going to print 20 extras tomorrow just to make sure. I'm going to get to the bottom of
They'll
this.
probably take them too.
I'm going to keep them up here, okay? Separate from everything else. It's annoying. I'm sorry. It's pissing me off.
Because they love
I'll post these online, though. So it's on Google Classroom. It will be. So section formula. We know, right, here's a segment. Cut it in half. Cut the vertical and horizontal in half. Where they connect is where the midpoint is, yeah? We've done that. Turn the page. So now here's midpoint formula. The average of the x's over the comma the average of the y's, right? Nothing new. Here's section formula. Not Alexander. Isaac Newton, okay? He discovers gravity, or at least writes the equation to figure out how fast things drop. It works for objects our size. Objects including pens, ourselves, mountains, and ants. Okay?
ants.
It doesn't work when you get to microscopic. No, it does work at microscopic. Subatomic atoms, right? It doesn't work on the scale of the universe. We want gravity to work all the time the same way, right? Because we know it does. So how do we write something? Well, it turns out Einstein comes along and says, your equation that you have over here works in the general sense. But as soon as we want to both apply to our size, the universe's size, and atom size, a little bit more going on under the hood. You just didn't notice it because it was so insignificant, it didn't show up in your calculations. Right? It was imperceptible. But when you get to the size of planets, you start noticing it. So check it out. We're adding in. See how these are the same? X is added together. Y is added together. Why are we not subtracting? Because we're not looking for distance. We're looking for the average, right? Notice the difference. M and N. Where does that come from? M and M is the ratio of the parts. Now, what is the ratio of half to half? 1 to 1. So what happens when M and N are 1? What's X2 times 1? X2. What's X1 times 1? Same thing for the Y's. What's 1 plus 1? M and M were there the whole time. They were hidden as coefficients next to X. It was 1. Why write it? They had the 2. Why write it? But what if you want to divide it in half? What if you want to divide it into thirds? Your ratio is going to be 2 to 1. So M is going to be 2. There's going to be a 2 in front of there. And a 1 in front of here. And when we add them together, what do? What's 2 plus 1? 3. So what goes underneath? 3. So you do divide by 3. But you have to weight it differently. Check it out. Let's pull out Saddam. Here we go. So we're taking out Saddam. Here's the ruler. Now, for a ruler, this is why I need a camera for the classroom. The balancing point is the middle. But what if I don't want the middle and the balancing point's a little bit side? Maybe this side is heavier than the other side. We have to weight it differently. We have to put a number in front of the X to make it count for more. Your homework is that and it's this, okay? It's all of the above. Here we go. It's gonna be great. I swear to God. Did you guys already take homework? You did not take homework, right? You must have it over here. All right, right here. Here we go. As you're going out the door. It is homework. It's over distance formula, midpoint, and section. Try out section. We're going to work on it tomorrow. Don't get too distraught, okay? Nice job today. I'm proud of this class. You guys kicked butt. I'm so glad we got it on tape. My day. Tell Autumn I'm very sorry and I miss her, okay? Good job, kid. Hey, can I grab this? Tom, can you in there? You did an alright job today. Hey, this is part of the discussion. There you go. Good luck, kid. Nice job. Yeah. There you go. Hey, there's some real questions in here that take real mind to solve, and you've got one, so make sure you do it, okay? You too. Talk.
Yeah. Are you gonna be the baseball coach?
I don't know. Maybe. I'm thinking about it. Depends on what my free time looks like in the spring.